Okay, so looking at the warm-up. All right, where is coordinate D at? Where's it at on the line? What number is it at?
0.
At 0. Where's C at?
2.
At 2 and 3. I mean E, sorry, negative 3.5. All right, so how long is line segment BE? So BE is from -4 to -3.5. So how far is it from here to here? Okay, now remember when we talk about length? Length is always just positive. Right? Because like, for instance, if I were to talk about, I'm 6 feet tall. What if I said I'm -6 feet tall? What would that mean if I was -6 feet? Like, it just doesn't even make sense. So when you're talking about length, it's always positive. So how far is it from here to here?
0.5.
Good, it's just 0.5, just half of a unit. All right. How long is line segment DB?
6.
Okay, so D is at 0, and B is at -4. So how far is it from 0 to -4?
Oh, it's 4?
Yeah, it's just 4 units. From 0 to -4, it's just 4 units long. And then E to C. So how far is it from 2, positive 2, to -3.5? 2 to -3.5. So how far is it from C to D?
2.
It's 2 units. How far is it from D to E? 3.5 units, right? So together, how long is that whole segment?
5.5.
It's 5.5. Yep. So the stuff we're looking at today is similar to what we did yesterday. We're going to add one little thing to what we did yesterday. So as we look here, so on example 1 here, it asks us to find the length of EF. So EF is right here. Okay, so what we're going to do is this, is we're going to say ED plus DF equals what? If I take ED, line segment ED, and add DF, what's it going to be as far as the letters are concerned? What? Okay, for the
3.1.
for the letters. I'm talking about the letters. We'll get to the numbers in just a second. So if I have ED plus DF
EF.
is going to equal EF. Good. Equals the whole thing. Okay, so how long is ED? 1.2 plus how long is DF?
1.9.
1.9. Okay, and that equals however long EF is.
3.1.
Okay, good. So that gives us 3.1. I mean, that's super simple. Super simple. You just add those two up. Makes sense. Okay, so that's about as basic as it gets, really. And we had something a little bit more difficult like this, and we're going to practice more with this today. Okay, so on this one, I'm going to do the same thing I did over there. I'm going to go AB plus BC equals what?
AC.
Equals AC. Yep. All right, so what I'm going to do is I'm just going to plug in. So how long is AB?
X.
Is X. Plus how long is BC?
Plus 2x.
It's 2X. And then how long is AC?
2x plus 5.
2X plus 5. Yep. Because right up here, A to C, it says that whole thing is that right there, 2X plus 5. Okay. Now what I need to do is combine like terms, first of all. So over here on the left-hand side, what is x plus 2x?
3x.
It's 3x. So I have 3x equals 2x plus 5. Now I need to get my x's together. So I have 3x over there, 2x over here. What do you think we should do?
Negative 2x.
Yeah, subtract 2x on both sides. That way these zero out. And over here on the left-hand side, what is 3x minus 2x? Okay, it's just a 1x, or x, however you want to write that. And then on the right-hand side, it's just 5, so x equals 5. Which if I take that 5 right here and plug it back in up here. So if x is 5, how long is this BC?
10.
2 times 5 would be 10. Okay, if x is 5, how long is it from A to B?
5.
Just 5. And if x is 5, how long is this up here?
15.
15, which you could think of that two ways. You could just do 5 plus 10 is 15. So that's one way. Or you could take this 5 and plug it up here. What's 2 times 5?
10.
And 10 plus 5
15.
is 15. So two ways to do the same thing. Okay, let's look at this one right here. So on this one, I'm going to write this statement again. AC plus CB equals AB. So how long is AC?
6.
Okay, good. So AC right here, you can see from A to C, this distance right here, A to C is 6 units long. A to C is 6. Plus, how long is CB?
2x plus 10.
Good. From C to B, you can see that right there. They tell us it's 2x plus 10. And then AB, the whole thing from A all the way to B, how long is that?
36.
Right there is 36. Okay, so first thing we do is combine like terms. So I've got a 6 and a 10. So what's that going to make?
16.
16. So I'm going to have 2x plus 16 equals 36. Nothing changed at 2x. I just brought it down. The 6 plus 10 is the 16, and then just nothing changed at 36 yet. Okay, so what's my next step here?
Negative 16.
Minus 16 on both sides. That way this zeroes out, and this leaves 2x equal to 20. And so x equals what?
10.
X equals 10. Which, we already know this is 36, and we already know this is 6. So really, from here to here, I mean, yeah, it's got to be 30. But also, if you plug in 10, 2 times 10 is 20 plus 10 will be 30. Okay. I want you to try the same thing on this one. Write out the statement with the letters, plug the values in, and solve for x on that one. Okay, so you get DE plus EF equals DF. DE is 22, EF is 3x minus 6, and DF, the whole thing is 40. Now the first thing we need to do here is combine like terms. So the 22 and the negative 6 are like terms. They're just numbers, just constants, just without any variables or anything. So 22 with the minus 6, 22 minus 6 is 16. So the 3x, nothing changed that. The 22 minus 6 left us the 16, and the 40, nothing changed that. So we're going to subtract 16 from both sides. This zeroes out. We get 3x equals 30, 24. Divided by 3. And x equals 8. All right. This one we already know this is 22. We know this is 40. If I plug in 8 up here, 3 times 8 is what?
24.
And 24 minus 6
That's 18.
is 18, which makes sense. Also, another way to think about that is super simple. You could have done 40 minus 22, obviously, and that'd give you the 18 also. So several ways to get to the same place there. Okay, that's exactly this type of stuff we did yesterday. All right, so let's go ahead and flip it over. All right, this top part right here is like what we did on our warm-up. So on this example 1, how long is line segment AB? You could count it. Also, you could just think about the numbers down here. How far is it going to be from -4 to a +2? It's going to be 6. Exactly. You heard somebody say that. Because from here to here is 2 units. From here to here is 4 units. So, together, obviously, that's 6 units total. Or you could just count it. The counting does mess some people up because if they count it, they're always like, okay, if I start here, do I count this as 0 or do I count this as 1? And the answer is you count it as 0. So it's like 0, 1, 2, 3, 4, 5, 6. Or the other way to think about it that I think is better is not necessarily the lines, but like the spaces between, like this is a full space. There's 1 space here, 2, or not space, whatever, there's bar there. So there's 1, 2, 3, 4, 5, 6 pieces between there. So AB is 6 units long. Okay, so right down here on these, I want you to work through those 8 problems real quick. Write down how long each one of those segments is. Okay, so how long is BD?
6.
Yep, it's 1, 2, 3, 4, 5, 6. Or you could think about it as -1 to -7 is 6 units. Okay, so it's 6. And how long is DG?
9.
Okay, so D is at -1 and this is at 8. So from -1 to 8 should be 9 units. Okay, AF.
12.
Okay, so this one's -9, this one's 3. So that's what you did, you dropped down instead of going over when you said that. So yeah, there's 12. Okay, how long is EF?
3.
3 units. How long is BG?
15.
Okay, from -7 to 8. Yep, it's gonna be 15 units. Okay, how long is it from A to G?
17.
So from -9 to 8 would be 17 units. How long is BE?
7.
From -7 to 0. Yeah, so 7 units. And then how long is DE?
1.
It's 1 unit. Good. You're all over that one. Okay. So we did all that stuff yesterday. Basically just reviewing. The one new thing we're going to throw in today is the distance formula. Okay? So that is this thing right here. This is the distance formula we're going to be talking about today. Which, from my experience in the last few years, the Algebra 1 team has, y'all generally have come to me knowing this formula pretty well. So I think that's probably where we're going to be at again. All right, so that's the formula we're going to be referring back to. I'm actually going to rewrite it down here. So it's x2 minus x1 squared plus y2. You don't have to rewrite if you don't want. I'm just doing it so I can have it done here where we're working. Okay. So what we're going to do is we're going to go in here and label our points and then just plug them into that formula. So the way I'm going to do that is this is my x1 and my y1 coordinate. And then this is my x2 and this is my y2 coordinate. So we're going to label them first like this. Now, it's easy to get this confused, okay? In any ordered pair, you always have the x first and then the y. That's the way it always goes in an ordered pair. The x comes first and the y comes next. And so what we're saying is 0 is the x coordinate from the first point. 0 is the y coordinate from the first point. Okay? So both of these should have a 1 here. You shouldn't have x1, x2. That's a common mistake people make. So you should have x1, y1. Here, this is the 6 is the x value from the second point. 8 is the y value from the second point. This is our first point. This is our second point. So x of the first point, y of the first point. X of the second point, y of the second point. So all I'm going to do now is take these 4 and plug them up into here. Okay, so what is my x2 value?
6.
Is 6. Okay, minus. Okay, so notice there's a minus in the formula, so minus goes here automatically. So what's my x1 value?
0.
Is 0. Okay, squared plus, and then in parentheses,
8.
my y2 value, right here, y2 is 8. Minus, okay, my y1, what's my y1?
0.
Is 0. Squared, okay, then I'll take the square root of that whole thing. So what we're going to do now in your calculator is you're going to type in that exactly like that. Yes? Yeah, hurry up. Okay, I want everybody in your calculator, type this in. I want to come by and see it in your calculator. Just go ahead and go. Yeah, you're good. Just go ahead. Okay, so we're going to type in, all right, so the square root, if you'll notice it's right here, so you got to push the control, you got to push that first, and then that. So you got to push the gray button, the control button, and then this one right here, and you'll put the little square root symbol there. And now you need to put in the parentheses, everything just like that. So I'm going to go parentheses. 6 minus 0, close squared, plus open, 8 minus 0, close squared. And notice how it's all underneath that square root symbol. Sometimes people get out from underneath there. It needs to stay, all of it needs to stay underneath there. Whoa, sorry. Just like that. Okay, and so what is the answer to that? 10. So what that means is if you were to get on an XY grid and plot those, A would be here at 0, 0, and B would be like at 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8. It would be up here. This would be B, this would be 10 units long. That's what we're doing, is we're finding out how long that line segment is. Okay, so number 10, let's label this. We have x1, y1, x2, y2. All right, so we're just going to plug in. So again, what's my x2 value on this one?
3.
Right here, x2 is 3, so I'm plugging in a 3 there. So in parentheses, I'm going to have 3 minus. Now again, remember the minus is built into the formula, so I always automatically put that minus. What's my x1 value?
2. Negative 2.
Is negative 2. So this is where we have to be careful. Remember, I put this minus here because of the minus in the formula, so that goes there automatically. Now, the x1 has a negative, so I'm going to write a negative 2 here, like this. Which, what's going to happen to these two negatives?
Turn to a positive.
They're going to become a positive. So whenever you type this in your calculator, if you want to put a positive there, that's fine. Or you can write minus negative. If you see that, putting a positive in there really eliminates some problems because sometimes putting the minus and negative causes problems of trying to make sure you know which symbol to put in there. So if you put the positive there, it makes it easier, but I'm going to leave it like that for now. Okay, plus, all right, what's the y2 value?
15.
15 minus, what's the y1?
3.
3. So I'm going to go 15 minus 3. Okay, I want everybody to type that in your calculator, and I'm going to come by and see it. Okay, good. Looks like everybody's got it, so that equals 13. So again, what that means is from this point, R, to this point, S, if you were to find the distance between them, it would be 13 units from that one to the other. Okay, do number 11 real quick. Find the distance from point M to point N. How far is it from 1, negative 2 to 9, 13 on an XY grid? Give you?
17.
Should give you 17 units.